Alright, welcome to page 3. And all we're going to do is we're just going to find the curvature of two vector functions. And we're just going to use two different theorems. And so we're going to start off with what we did with the last page. I guess this is page 4. And we're going to do the curvature of the curve given, which is ti plus t squared j plus e to the tk. And I'm going to go ahead and I'm going to find the derivatives first, and I'm just going to go ahead and put them in just the vector notation, not standard basis notation. And so derivative of t is just going to be 1, derivative of t squared is 2t, and derivative of e to the t is just e to the t. The derivative of the second derivative of our vector function is just going to be 0, 2, and e to the t. Now, let's go ahead and plug in our formula. So kappa of t says that we need to do, and what I'll do, instead of doing kappa of t right now, I'll just go ahead and do I'm going to go ahead and do the cross product of the two derivatives. So the cross product of these two, and then also we'll take the magnitude. So I'm just going to do the numerator and the denominator separately. And so to do the cross product, I have 1, 2t, e to the t, and 0, 2, e to the t. And when I do the cross product, I'm going to get the vector 2t times e to the t, so 2t e to the t. And then I'm going to get minus 2e to the t. And the second one is just negative in front. 1 times e to the t is just e to the t. E to t times 0 is 0. And then cross product again. 1 times 2 is 2. 2t times 0 is 0. And so that is the cross product. Now I'm going to go ahead and take the square root of that. And so now I'm going to take the square root of, or do the magnitude, so 2t e to the t minus 2t 2e to the t squared plus negative 2 e to the t squared, no, not negative 2, but just e to the 2t. So plus negative e to the 2t squared plus 2 squared. And that's going to give me, what I can do, I can take out those e to the t's, and then this e to the t, and then they're all going to become e to the 2t. So to kind of simplify it, e to the 2t, I'm going to pull that out, and I'm going to be left with 2t squared, which is going to be 4t squared. 2t times negative 2 is negative 4t, so negative 8t. Negative 8t. And the negative 2 squared is going to be 4, but then I have that 4 plus a 1, so it's going to give me plus 5. And then I have this plus 2 squared, so plus 4 on the outside. So that's going to be the numerator of kappa. The denominator of kappa is going to be just the magnitude of the derivative and then cubed. So the magnitude of the derivative is just 1 squared plus 2t squared plus e to the t squared. And that's going to give me the square root of 1 plus 4t squared plus e to the 2t. And all of that's going to be now taken to the third power. And so my final answer is just going to be kappa of t is equal to the cross product of the derivatives, the magnitude of the cross product of the derivatives, all over the magnitude of the first derivative cubed. And so that just leaves me with the square root of e to the 2t 4t squared minus 8t plus 5 plus 4 all over 1 plus 4t squared plus e to the 2t. And I'm just going to raise that all to the 3/2. And there's your solution. All right. Again, you can't break it down any more than that. But then again, you know, usually we'll be having some values for t that we can go ahead and put in. But that's all that we have. The second one, there could be a special case of a plane curve with equation y equals f of x curvature. And, you know, if that is ever the case, what we can do is we can go ahead and solve using our formula. Kappa of x is equal to just the magnitude of the second derivative of our function all over 1 plus the derivative squared of that taken to the 3/2 power. So another way that we can find the curvature. And so problem 27, we want to find y equals x to the 4th. So we go ahead, we first go ahead and find our derivative. So f prime of x is going to be 4x cubed, and f double prime is going to be 12x squared. And so for a kappa of x, that's just going to give us the magnitude of 12x squared. And then the denominator is just going to be 1 plus the derivative of 4x cubed squared, all that taken to the 3/2 power. And so if we're the magnitude of 12x squared, well, that's just going to give us 12x squared in the numerator. And then in the denominator, we have 1 plus 16x to the 6th power taken to the 3/2 power. And that's it there. So we're finished. 1 plus 16x to the 6